Miss Jody here for another video for the Earth and Space Science class that meets on Tuesdays, 9:30 to noon. Well, last week I was working on some projects at the Science Center. I'm going to send you a video. We did get our flooring done for the animal room that was destroyed. Mr. Gary took up all the old flooring and replaced the new flooring, and I'm going to send a video for you to see that. So we're really thankful, and I've been working on that. And so that's what delayed me just a little bit in getting our lessons started back up here. So we have this lesson, which is the history of space flight. And that's going to finish our chapter 11, and then we only have one more chapter left in the book, which is the environmental science, which is chapter 12. So we're almost done. Can you believe it? And obviously, we still haven't been able to get back together, and I'm not sure what the time frame that will be, but I still have left some spots for picture taking for our experiments, and I still would like to have all the notes taken on little half sheets of paper so I can glue them right there underneath the lesson tab of your journals, and I'm getting all those together. I've been working hard on getting the high school classes all finished up and tabbed up so that if they need to pick theirs up early for their assessments, they can. And then I'm going to be working on the younger level, your class, and then the other Thursday class, and getting all those ready for you guys too, just in case some people have to pick them up early. But hopefully we still can get back together. That's still my goal, even if it's at the end of May or early June. We're not opposed to summer school, right? Even if we could get 1 week together would make me very happy. And then maybe 1 week of experiments, and then maybe a second week, which during the experiments I could take the pictures, and then the second week, during that time I could glue them all in, and when you come back the second week, we could have a little party, end of the year picnic or something, and then take your journals home. All right, but so that's my hope. All right, so we're finishing up this last chapter on the history of space flight. So we did start this at the beginning of the unit when we turned our eyes to space, because as you remember, we've been studying for almost the whole year the Earth and all of its systems, and the hydrosphere and the lithosphere and the air sphere, the atmosphere, and all of that, weather, and just all of those components that we studied with the Earth. And then we turned our eyes to space. And so this last part of our unit with space, we started, if you remember, I think it was our last week together, we started a video on the history of spaceflight. We saw NASA, how it was formed, and some of the old technology that they used to use, and really cool things about how the rockets were being built. So let's continue on with that topic here, okay? So in our book, it starts with the history of spaceflight. It starts with focusing on basically the time when the rocket began to be used to try to get the space probes and the satellites, and then eventually man into space. All right, so rocket, what is it? A cylinder projectile. That means something that's a cylinder, I can't say that word, cylindrical. Yeah, there, cylindrical projectile. Now remember, if you're a younger student and you're taking notes, you don't have to write out all of these notes, and even the older students, you don't have to write out every single word. Just write out a few things that helps you remember those concepts. So like younger ones, you could just write the word rocket and then just draw a rocket. And when we get to hear solid fuel rockets versus liquid fuel, you could just do solid and liquid and stuff like that to make it easier, okay? Or just draw me some pictures for that topic. Okay, so the rocket, so it's a cylinder, that's a projectile, that can be propelled to the great height or distance by combustion of its contents. That means there's going to be this cylinder type projectile that's going to be shot up. In the way that it's shot up to a great height or a great distance is through the process of combustion. So combustion is a burning chemistry situation where you're going to burn something. And so with the burning, we have different types of fuels. So we have the solid fuel rockets versus the liquid fuel rockets. So our solid fuel rockets, they used to be called rocket motors. And they date back to the 1200s. And this is what was used for, and even used now some in the fireworks world. So solid fuel would be something that would actually be solid, like gunpowder, really compact solid material that you catch on fire. Small military rockets were of the solid fuel rocket type. And with that solid fuel gunpowder, like I said, what's convenient about these is that it does take them a long time to pack the solid material in, but then you can store it for long periods of time. Like you see with fireworks, you don't have to repack it when you get the firework out. It's stored in there because it's solid. Now, the difference then of the liquid fuel rockets is instead of using a solid combustible material, we're going to use liquid. And so these liquid fuel rockets, they were called rocket engines back in the day. In 1926, Robert Goddard, who's known as the father of modern rocketry, he was the one who began starting this liquid fuel side of things. And what you do is you use liquid chemicals, and these chemicals, they expand greatly when they're reacted with each other. So basically you react chemicals to create an expansion in this process of the combustion, the blowing up kind of thing with the rockets that you see in a normal rocket launch. And so these two different types of rockets got us going. So as the history of space flight, we start saying, okay, once we started figuring out the rockets, then it was game on. We were going to try to figure out how to get to space, and then once we got to space, what to do with all that space world, right? And so this marks the space age begins, the beginning of the space age. Now, as you see in our video, we had already started watching the race between the Soviet Union and the USA in trying to get to space and to understand space flight and escaping velocity and all that. And of course, like we saw in the video, the Soviet Union beat us. They beat us really with their first one, Sputnik, number 1, October 1957. So they launched Sputnik in November 1997. So then a month later, they launched Sputnik mission number 2, and they put a dog in it. Lakia, I think it is. And so that dog went up into space. So they were really on it. Then there was a time after they got going that the U.S. finally got going. And I see how I kind of stagger this because they were the first ones to get going, and then later. So that was November 1957. Then the next year, January, the beginning of the year, so only a couple months later in 1958, then we launched the Explorer. Now my book is getting so bumpy here. You can barely see it, but there, Explorer number 1. The first one. So then we started getting going, trying to launch things into space and figure it all out. And then, so that was 1958. And then back over here in April of 1961, the Soviets again beat us by putting the first man into space, Yuri, how do you say it? Gagarin, I think is how you say it, Yuri Gagarin. And so he went up into space in 1961, and then we were like, oh man, we better get a guy in space. And so May of 1961, so this is only a month later, so they were in April, a month later, we launched Freedom number 7, which was the Mercury rocket, with Alan Shepard. And he just went up for like a 15-minute kind of orbital kind of hop thing, which is kind of like not a full orbit, and for a small amount of time, and then, but it was still something. And then in February 1962, we had Friendship. So this was Freedom number 7 was the first one with Alan Shepard, and then Friendship number 7 took up John Glenn, who gave a full orbit, and so we increased our time up there and was able to show we were just as adequate as the Soviet Union at the time. That was in February of 1962. And then in June of 1963, a year later, the Soviets put up the first female, the first lady in space, Valentina Tereskova. Valentina Tereskova. So she was the first lady in space. And then after we had put John Glenn up there, and then that was in 1963, before that, I should say. So the first lady in space, and then in the year after that, in 1964 to 1965, they had the next mission, the Voskhod #1 and #2, that they were actually sending astronauts up, and they were actually going out on spacewalks to be able to like repair things, and so they were getting really experienced in understanding how space worked, and so we were like, we better get on the ball. And so in March of 1965, which was towards the end of this, or the beginning of this year when they were still doing their two, we launched the Gemini program. And Gemini program had a ton of progress in space, because we were able to send, just like they were sending men up into space, and they were creating the spacewalks and learning how to figure out what was going on up there and what you could and could not do. And our spacecraft, Gemini, was really maneuverable, and we could dock it and maneuver with other objects. And so we kind of got really fancy once we got into the Gemini world. Okay, and so then after the Gemini is then when we have the embarking of the Apollo program. And the Apollo program kind of marked us finally getting ahead. So if you look at this race here, they're ahead, and every time they get a little ahead, we try to catch up, and they start doing this, and we start doing this. But then eventually, when we get to the Apollo time, that's when the United States of America kind of takes the lead and starts showing a lot of ingenuity, and we become the ones who are doing spectacular things in space that are kind of beyond the normal of the time. And so with the history of space flight, and the next page is going to be about the Apollo one, but I did leave this little spot here because what I thought we could do, let me move this book out of the way here, is to kind of have some stuff at home again, so our journals aren't so empty. We could create some rocket type of art craft for our beginning of the history of spaceflight. So what I did is I grabbed some rocket artwork actually from my STEAM program, because we did a lot of space art this year, because our art for the physics was on astrophysics. And so I'm just showing you a couple of these from some of my students. So here's one that someone did. I thought that would be that was a chalk pastel. They did the chalk pastel background, and then they made a rocket and glued that on. I think they painted the rocket there. This is another one that was super cool. It looks like it's kind of a Mars look, and they're inside binders. That's for their art, and or like plastic things. That's why they're kind of got a glare there. That one was really cool. This one, one of my students did, I thought was really cool. That's a rocket there. I just grabbed a few out of their binders, and that's a cool rocket picture. And this one I grabbed out. So I just grabbed a few to give you some ideas of creating some sort of rocket. Now, it doesn't have to be chalk pastels or painting or anything like that. I'll probably make a little rocket. And you know how I always have to have like fladuzzle and glitter and all that kind of stuff. I'll probably have fladuzzle down here blowing out and stuff. I'll put something together, and next week on my last video for our last chapter, I'll show you what my rocket ended up looking like. Okay, so if you have something at home, it doesn't have to be black construction paper. It can be any half sheet of paper. Create me a nice little rocket picture that can go right next to our history of space flight. That would be awesome. And then also take a picture of it and send it to me, because you know that really brightens my day when I get pictures attached to the online classroom. Okay, and that will be great. So continuing on, after our war with the Soviets and moving on, then finally once we got to the Apollo program, we started to really seem to get ahead, I guess, a little bit, even though everybody was still working on their programs. So the Apollo program, and this is another half sheet, so each time I get to a new page, obviously, you're going to have to get another half sheet, even though this one doesn't have a title. This would continue on with our history of spaceflight here. So the Apollo program, America finally takes the lead during the Apollo time, and the spacecrafts that they were designing during the Apollo years, they were designed for more than one astronaut, 3 astronauts in particular for the ones that we are going to talk about here. And so these spacecrafts were designed so that multiple people could go up, and then if we were going to the moon, because there were some other ones prior to this, if we were going to the moon, the Saturn V, which is that famous rocket you probably have heard of before, the Saturn V is a big 3-sectioned launcher and a very powerful rocket. And so moving up in the Apollo program, we had Apollo 7, 8, 9, and 10. These were all leading up to the main one that is our famous one, the historical Apollo 11 that actually finally landed on the moon. But these particular missions were doing a lot of getting ready, figuring it out. So a lot of times in spaceflight, we have pre-missions, things that need to be done in order for us to do the big thing that we're planning. Okay, so on July in 1969, we had that lunar landing. And I'll send you a video on that, giving you some of the history so you can see some cool pictures of that. And then and the mission continued on, and then so there was, Apollo 12, Apollo 13, all that. Once we got to Apollo 17, that was the last of the Apollo missions, December of 1972. Okay. And so the age of the Apollo, the time when the Apollo really set us apart in the space race. And then after the moon and all that, there was a lot of focus on orbiting space stations, creating these orbiting space stations. Now with these orbiting space stations, we had the Soviets again and the US. They were kind of still working head to head. And at this point, it was just the Soviets and the US. Then eventually China gets on board and they create their own missions and they start going into space too. But at this time, these are the two main ones. So the Soviet Union, for the orbiting space stations, they started with the Salyut program in 1971, and they put up this orbiting space station, and it had things on it like spy cameras, defensive cannons, missiles, a science laboratories, telescope, things like that, so that it could be used for multi-purpose study. And it finally saw its day in the end in 1991 when it re-entered Earth's atmosphere to burn up. So a lot of times when these things are put up in space for a certain amount of time, then eventually they'll be brought back down and burnt up when they're done with them. So they had theirs in 1971. So then in 1973, we launched our own orbiting space station called the Skylab. So ours had science labs, even had a shower on it for astronauts to be able to use, living quarters, special telescopes. So it wasn't as fancy as like the International Space Station is now, but it was the beginning of orbiting space stations around the Earth. And then the Soviets put up Mir or whatever in 1986. And so after the 1973, I should say the Skylab was burnt up in 1971. Too. So I should probably do this so it looks like burning up as it re-enters the atmosphere. 1991 on this one, when they were done with it. 1971 when they were done with this one. Looks terrible, doesn't it? Maybe I could put a little yellow highlighter. Grab that real quick. That way you can say, okay, these guys, this one was burnt up when it was done. This one was burnt up when it was done. Okay, and then Mir, when they put that one up in 1986, it actually has started having modules. I think that's kind of the base for what ended up being the International Space Station, in the sense, not the base, but a plan model. Just knowing you could put modules that could be built on each other. I had science experiments, military experiments, and all that on it too. It actually has the longest lasting cosmonaut for staying on it on a space station, and this is still, I think, they said the what's it called when you're the only one that's done it, world record, but I'll have to check on that. But 438 days one cosmonaut stayed on the Mir. That's supposedly still the world record. That's a long time. That's a year or so to be in space like that, and we know how hard it is to be in space for our bodies. And then this one finally was put to rest in 2001. I'll make it exploding here too, back into the atmosphere. And then last but not least, so that was in 1986 when they put that one up, and then it burnt up in 2001. But last but not least, our little ISS project, the International Space Station project, that was put up in the plans, I should say, were supposed to be for 1990, but it really didn't come together till 1998. And then in 2000, the year 2000, that was the first crew that came to the ISS. So the ISS, obviously many nations joined, so it became the International Space Station, so not just US only, which is, I think, one reason why it's so successful. We have lots of brilliant minds from different countries working on it. And it was finally completed, they say, in 2011, like a real completion of what they were building. And they built it over many years and put different modules together. And now it has a whole bunch of cool things. And I'm going to attach a video of a tour of the ISS if you'd like to watch that to see what it's like being in. And you can see there's no burn up for the ISS yet because it's still in operation. And so these three were eventually burnt up when they were done with them, and the ISS remains as the main orbiting space station of the time. Now, next to this page, because we did talk about the Apollo program, I thought we would do a little moon. And so what I've done is I've just taken a piece of paper, like a brown piece of paper, and I just did a bowl on it. And then I just, I took that and I drew a little circle around it. So I'm just not too hard. I'm going to move that so it's a little easier for you to see. So I just took my pencil and just tried to draw a little circle around it just so it would be easier for me to cut. And I obviously can't do it right now, but I was doing a good job of it. And then, I guess I got something on that paper there. And then I just cut that little circle out. And when I cut that little circle, I just glued it on another piece of paper. And what you could do is I could go ahead and put the black in the book so it's ready, and then you could make your own moon. And then whenever you either bring me your half sheets to glue into your journal, or if you want to drop them off at the Science Center, I'm going to put a thing out front of the Science Center where you can drop all your notes off in a little baggie and any of your crafts for me, and just put your name on them, and I'll get them in your journal. I'm going to put that out by the front door where we have our dig pits. I'm going to just put a little bucket out there, and you can just drop them off in a little Ziploc baggie, and I'll get them all glued in for you. So if you don't want to worry about the black paper, I could glue the black paper in, and then you could just make a moon for me. So it could be out of any type of paper. And then I thought, to make it exciting, you know how I love to do the little shaving cream and glue. After I'm done with this next set of notes, because I'm going to have to leave my book open to show you, then I'm going to mix up some glue and shaving cream, and I'm going to make it all puffy and put some silver and black glitters on it to make a cool little moon. But because I need to turn the page right now, I don't want to do that because then it would stick to the page. So I'll do it at the end. All right, so the next one is about unmanned satellites. And so unmanned satellites, so after we started doing orbiting space stations, then it was like, hey, we got all of these other things that we can do with our space world. And so we started having a lot of unmanned satellites going up into space for many different purposes. Now, a satellite is anything that's going to be orbiting a body of mass, and so our moon is a natural satellite, but these are going to be artificial satellites, ones that we put up and cause them to orbit. And so we have in the unmanned satellites, let me put this book back underneath here because my book is so bumpy, it's hard to keep it so you can see it there. This side page is really getting bumpity, isn't it? All right, so of the unmanned satellites, we have the astronomical satellites, and those astronomical satellites, there's a purpose for those, obviously, to study astronomy. So in the astronomical satellites, they're put up there so we can figure out what else is out there. So it's filled with sensors and instruments to assist astronomers in studying space. So we have a lot of astronomical satellites. Hubble, the James Webb that's supposed to go up in March of 2021, the Spitzer, Kepler. There's a whole bunch of astronomical satellites that are made to orbit our Earth, but in the orbiting of our Earth, they're looking out into space to see what else is out there. So you've got the astronomical satellites. And I'm going to kind of circle these just to make them stand out a little bit, okay? And then you have communication satellites. Communication satellites are, what's their purpose? Well, communication. So they're the satellites that we have, the satellite telephones, because sometimes if say you're out in the middle of a desert, well, there's no cell towers, you can't use your cell phone, you got to have what's called a satellite telephone or a satellite cell phone, and that way it uses the satellite to communicate because there's no cell towers.
television broadcast, are you the communication satellites? If you ever have satellite TV, satellite radio, even satellite email and internet for certain circumstances where we're not using the regular, or even SOS, meaning these satellites can be used for reaching out in times for like the boats and stuff. If somebody's in trouble, they can use the satellites to get help for like a sinking ship or something like that. And so communication satellites are all about communication, right? So the astronomy ones, studying astronomy, the ones that are helping with communication. Then there's the weather satellites, and these are the satellites that obviously are studying the weather. The meteorologists use these. These are continuous views of what's going on in our atmosphere so we can track it. There are different types of orbits that these different satellites can be on. One in particular, the polar orbits. And I am going to move this over for a second to show you. And maybe if I can take my book's so big, if I move it over here, then you can't see that page. Let me use 3 colors here. I'll use purple, green, because the little diagram that I'm sending you, it's going to be hard to see because it prints out so dark. I don't know what's going on with our printer. I'm trying to get it to be a little lighter here. But you see on this diagram, I'm putting this in green. This is the geostationary orbit. So these are orbits which would be going this particular way. And they're stationary, looking at a point. And then we have the low Earth orbit. So I'll put the low Earth orbit right here. It's really dark, so you can't even see it. But once you look at your diagram, maybe you'll see it. These will be some satellites that will be orbiting very lower in the Earth's atmosphere than these ones that are farther out. And then the polar orbits. These are ones that are going to be going kind of up and down, going over top the polar regions, down by Antarctica and up by the North Pole. And so depending on what your purpose is for your satellite, it might be in a different orbit than maybe another satellite that's out there. Now, when you look at this, it doesn't look like there's much going on, but I will be sending you this page. Now, don't print this one, but don't print out this page that I'm going to send you. I don't want you to waste that much ink, but I do want to send it to you just so you can get a feel, because I can print this out here at Science Center and glue these in your journals, but just to get a feel of like, wow, all of these different nations and all of these different satellites. I'm going to send you a video on the different satellites that are up around the Earth and all that's going on up there, because you almost don't realize how many are actually up there and who's tracking what and for whatever reason, because we also have commercial satellites that are for tons of different commercial companies too. And so I'm just highlighting this. This is the yellow to help us remember the sun, and that center would be the Earth, and they would have the same thing. They would have the what color did I use? Green. So they'd have the ones that are the geostationary orbits. So some of them would be out here in the geostationary. And then you would have some that would be the polar orbits. You can hardly see it on this, especially since I have it glued in, but they're kind of really light, and they're like right here, over up and down orbiting. And so you have these same sort of, and then low Earth orbits too, that would be having certain ones that are very close to the Earth here. Let me put this in, maybe in a yellow. Can't remember if I used those right colors there as the same. I should flip back and see. Okay, low Earth orbit, I used yellow. So yeah, I guess I did. Okay, so looking at some of that are really close to the Earth, some that are farther out in the geostationary orbit, some that are in the polar or the near polar orbits. And so when I send that video, it will give you an idea of like so many things up in space, and just to realize that it's, we think of it as like, oh yeah, we probably have 1 or 2 things up there. No, that's not really true. There's a lot going on up there. And with these satellites, I just happen to put 2 on here, just so you can see the difference here. This happens to be Hubble. So everybody's familiar with Hubble, and maybe you could study a little bit with Hubble and write some little information over here of what Hubble's discovered. And this is just a generic clip art of a weather satellite. You can write some information about weather satellite if you want to do some further studies on that. And of course, I will be printing these out at the Science Center too. So since this doesn't have much coloring on it, and if you decide not to do any extra studies, don't even worry about printing this out. I don't want to waste your ink. I will have them in your journals already, so you can. But if it's a diagram where there's a lot of coloring, where you really need to follow to understand, then always print those out, and then I'll just glue them right over top of the ones that I have in your journal. That way you have your actual notes that go along with it. But something like this where I only put a little color on it, don't worry about wasting that, okay? All right, so back to this. So we had the astronomy type satellites studying things out in space and what we're trying to figure out about space. The communications one, helping us with all the communications, our telephone, our TV, radio, all that. The weather satellites, following all the weather and looking at the polar orbits, the meteorologist. Then there's what we call the navigational satellites. And these are satellites that are going to be used by airplanes, ships. It's what if you ever hear somebody say, I got to use my GPS, my global positioning system, that is part of the navigational satellites that are actually helping us navigate. They also help us with keeping a specific time across the whole world with the atomic clocks, so that everybody has, like if you have a cell phone, your cell phone will automatically update your time when there's time changes, and you don't have to try to figure that out, which is awesome. So we're never late for anything when they have the time changes. And so those would be part of the navigational satellites. And then we have the Earth observation satellites, and these are satellites that are helping us with making maps across the world. If like Google Earth would be an Earth observation satellite. So they make maps, they can forecast crop production, they can see things from above, they can spot fires, they can track cities and figure out what's going on there. They can even track fish migration. That's pretty cool that they can see the fish in the water and track that in their masses. They can measure waves, how high waves get in like hurricanes and all that. They can map the ocean floor. Well, to some point they can see water levels, like when water are rising and lowering in lakes and reservoirs. They can track faults with volcanoes and all that. They can even find coal in different areas of rocks from above. So super cool, these Earth observation satellites. So you're probably really familiar with Google Earth. And then military satellites. And these satellites, these are ones that are going to be used by the military and mainly to defend the country. And so they can scan the earth, they have telescopes on them, they have very sensitive cameras that can detect different things like infrared and all that. So basically they can spy on foreign military too and keep an eye and make sure, like looking for anybody doing any bomb testing or anything like that, to make sure everybody's doing what they're supposed to be so we don't have any trouble. So just as a review, these unmanned satellites are ones that are going to be circling the Earth, either in the low Earth orbit, the polar, the geostationary orbit, and they're just keeping track of many things. Astronomical, keeping track of the study of things out there in space, the communications, keeping all the communications going, the weather satellites, checking the weather, the navigation satellites, helping us navigate, the Earth observation, checking and keeping an eye on everything in the Earth, and then, of course, the military satellites, those that are going to be used to help with the military missions. All right, so that's our unmanned satellites. And then again, like I said, this one that shows you different satellites up in space, don't worry about printing that out because I don't want to waste your ink, but isn't that super cool that so much is going on up there? And I will attach a video for that so you can see. And then last but not least for this chapter is unmanned space probes. Oh, unmanned space probes. This book is getting so big I can't even turn the page. All right, so unmanned space probes. So the other one was unmanned satellites. Those are ones that are going to circle the Earth. Now these are going to be unmanned, meaning no man is in it, and they're going to be space probes, meaning we're sending them out into space. We're not having them circle the Earth. We're having them go out and see what we can figure out. And so a space probe is an unmanned spacecraft launched specifically to explore the unknown. So it's going beyond our particular little bubble of life and trying to figure out what's out there. And with the unmanned space probes, the main thing is we have to figure out how to escape velocity. That means we've got to escape Earth's gravity pull on us, and we've got to be able to make it so that these probes can get out there and get going. And so escape velocity, it's the minimum speed needed for a free, non-propelled object to escape Earth's gravity. And what that means, it's an object that's not being propelled, meaning how fast you have to be going so that something that doesn't have any more propellant, no more fire to keep it going,
then can actually escape gravity and keep going. Meaning if I'm going to shoot up a rocket, I got to be going a certain amount. The speed has to be a certain amount, or gravity will just pull me back down. And if I don't have any more, anything else to blow up or to blow off to give me more thrust, then what is that speed so I can keep going and not get pulled back down by gravity? And so if we're ignoring the atmosphere, that escaping velocity is somewhere around 25,000 miles an hour. So just think about going on a ride, on a trip, and your mom or dad's driving 100 miles per hour. Well, that's not the speed limit, but how about 80 miles per hour? Doesn't it feel fast? Like it feels like you're going fast. Now imagine if you were going 25,000 miles an hour. And so that has to be a very fast rocket, a really powerful rocket to get you up to where gravity cannot pull you back down at the same rate and crash you to the ground. So we must escape velocity and then get our space probes up there so they can go do what they need to do. Now, with our space probes, there's what we call methods of investigation. And these methods of investigation means, what are we going to put on our space probe? What are some things we're going to do to investigate what we want to figure out? Well, that's going to be dependent on the mission. So if we're going to be trying to go look at Jupiter. Well, when the Juno project went to Jupiter, it had certain things. One specific thing about the Juno project is they wanted to measure the magnetosphere of Jupiter, because Jupiter was putting off all these really cool auroras, like what we have, the Aurora Borealis and the Aurora Australis, and Jupiter has amazing auroras, like way cooler than ours, and they wanted to figure out what was going on with theirs. So of course, on that particular space probe, they're going to put something to measure the magnetic field and try to figure out how these cool auroras work. And so the methods of investigation, they all depend on what you're trying to figure out. So I just listed a few of the unmanned space probes and kind of what they put on or what they were trying to figure out. So like, say for instance, Voyager 1 and 2. When they made Voyager 1 and 2, and we've already watched a video on that, they had TV cameras, they had infrared, I just put IR to make it simple, UV, they had ultraviolet detectors, because they wanted to figure out like what type of radiation was going on as the Voyager 1 and 2 went on its mission. Now, as we seen in Voyager 1 and 2, as we saw in Voyager 1 and 2, they had a certain mission to go past different planets, take pictures, and then these two headed out of the solar system. And remember, we talked about Voyager 1 still being viable and sending us back data after 40 years or something like that. So this is amazing space probe, and hopefully you watched that video I sent you. Another one, Galileo, was to look at Jupiter, as was the Juno project later on. Juno was a lot later than that. Cassini, that's another famous one that went to Saturn, and a lot of cool things and pictures that come out of Cassini with the rings and stuff of Saturn. Magellan of Venus, looking at Venus. And so if you're going to go to Venus, what would you put on your space probe? Well, you want to figure out to be a detector to look at the atmosphere of Venus, the temperature. So you would build your space probe for the investigation that you would want to happen for that particular item that you're trying to look at. And so that's what it means by methods of investigation. It's got to depend on, okay, what are we trying to do? Are we trying to collect something? Are we going to actually touch it? Are we going to fly by it? Are we going to orbit it? What are we going to do with these space probes? And what are we trying to figure out? A couple other ones, Viking, Pathfinder, Spirit, Opportunity, you know those, famous for Mars. Venera, Vega for Venus. The Mariner project, Mars, Venus, Mercury, Ulysses, studying the sun, New Horizons, a famous one that went to Pluto. So I just listed a few of these so you could do some investigation on some of these and see what you could figure out. Maybe look up some videos on those particular ones. I'm not going to link a bunch of videos because I'm going to have a video on the moon and then a video on this International Space Station. And was that the only one I was going to link? Maybe there was one more, but I know definitely those two I wanted to link for this particular one.
so that I don't want to put too many videos, but you can look at some of these and study them on your own. And what I did was I put on one of our diagrams. Again, you don't have to print this one out because it's just some diagrams, but if you do decide to, then you can write some information as you study them. This is a diagram of Voyager, so just showing you a little bit about what the Voyager looked like in each of the different parts. Now it's kind of hard to see on this one because it's very, very small, but you could look this up on the internet and get the bigger picture, and then know what each of these parts were for. This is Cassini. This is the one that went to Saturn. You can write some information over here if you decide to print this one out. But again, I will be printing these out and putting them in your journal, so don't feel like you have to print these type out that don't have much coloring on them. This is New Horizon, and the New Horizon project went to Pluto. And what I love, this one kind of illustrates it best, is how NASA, when they put their things together, when they create something that's going to be part of this space probe, a lot of times they'll use these acronyms to spell it, like REX. This part of it, REX, it stands for something. R stands for something, E and X, and so they name it like SWAP or Alice. Well, Alice isn't just the name they gave this little, oh, let's call her Alice or Sally. No, Alice went along with what this particular device does. So if you look up the New Horizon, you can look up these couple names. Pepsi, that's a funny one, Pepsi, but it was really Pepsi, I bet you. Ralph. Okay, what does Ralph do? Well, it means something. It's not just Ralph. We don't just call him Henry or Ralph. And so you can look up some of these names for the different parts on the horizon and what they were put on there for. What are they trying to detect? Are they part of looking for radiation? Are they part of looking for the magnetosphere? Are they part of looking for the infrared or the UV or the temperature? Are they the camera or whatever? So you can look up. This one, I think, is the best one to look those up because you can see them better than the Cassini one or the Voyager one. Okay, so these are just 3 ones I thought I'd throw on there so we would have a few to kind of do some investigations on. All right, and if you find any good information or if you even do any of these, you can also send me pictures of some of the diagrams that you do or any extra study, and I can put those in your journal, and then of course it just gets me excited to get pictures from you. Okay, and you can attach those right in the classroom. When you go to turn it in, it'll say if you want to attach something, you can attach that picture right to it. All right, so that finishes up our chapter 11, and then like I said, we only have just chapter 12 left, and that means we are almost done with this study of the Earth and space science. And so one more video I'll do next week, and then hopefully I'll have some announcement of when we can get back together. Hopefully we'll start making some plans for that. Like I said, I'd love to get back together the last 2 weeks of May, and if they don't allow that, maybe a little bit early in summer before our camp season. And of course, this will be optional because not every parent's going to want everybody to get back together because some people have different health issues. So it'll be optional. We'll have to see. Again, play it by ear. But worst comes to worst, if you drop off your stuff at the Science Center, I can get all your journals glued in. And if we can't get back together, I can put your journals back out maybe a week or 2 later, and then you can pick them up. And then you'd have your science journals from this year. Okay? So we'll stay in touch, and I will do a video next week and let you know if I have any updates. And until then, keep studying.